Okay, there are two other methods that you basically always have to write for your classes, and that's just because a lot of the Java language depends on the fact that they're there. We're going to write it for the rectangle class, but before we go and do it, I just want you to kind of see why it's important. So let's pretend that we've got some method here. I'm going to call it rectangle tester, and let's say that I create two rectangles here, each that are going to start at an x coordinate of 1 and a y coordinate of 2, and are going to have both a width and a height of 10, so they're essentially squares. So basically, if you look at these two rectangles are the same rectangle, right? They are equivalent. Well, it's nice if I can say if rectangle 1 dot equals rectangle 2. Dot equals is a method that is automatically inserted in every single class in all of Java. But the thing is that the default definition for this class isn't all that intuitive, so you'll see how this works. So you can see here what we're doing is I'm saying if the rect1 object is dot equals to the rect2 object, we're going to print out they are the same, others are going to print out they are not the same. And it works. But when I come into the rectangle class and I execute that rectangle tester method, you'll see that it says, I got the two I love very much. They are not the same. So for some reason, the dot equals method that is inserted automatically for the rectangle does not know that rectangle 1 is equal to rectangle 2. This is a problem, right? I mean, all of our intuitive senses would say that these two rectangles are identical. So basically what happens is in every class we have to go in and create an equals method that accurately defines what exactly makes one rectangle object equal to another object, or one object of a class equal to another object. Now, similarly, you may have seen on that worksheet we did before, you can throw an object reference into the parentheses of system.out.println. So notice here, I've got system.out.println, I'm just saying rect1. I'm trying to print up a whole object, and if this is not a string. Well, what happens is this actually will compile, and the idea is that when you insert an object in a string context, Java always executes the toString method that is written for the class that this object is from. So now let's go ahead and run the method, rectangle tester, and this is the string that pops up. And you'll see that it says rectangle, which is the class that we created the object from, then there's an @ sign, and then there's all this nonsense. You'll see there's A, C, D. This is hexadecimal. And the idea is this is the memory address where the object can be found. This is kind of interesting, but it's not very useful to us. So every single class that you will ever write is going to have an equals method inserted to it and a toString. By the way, this is the same if I just wrote dot toString, right? That's equivalent to what I'm already doing. And they're inserted automatically because it's important for us to be able to determine if two objects of a class are equal, and it's important for us to be able to represent an object as a string as much as possible while we debug. So when we write our classes, we have to write an equals method and a toString. Again, the goal of the toString is primarily for debugging. Okay, so here I am in the rectangle class. Again, if you remember, I have two double instance variables that represent the x-coordinate and the y-coordinate of the upper left-hand corner, and I've got two doubles that represent the width of the rectangle and the height of the rectangle. And I've got my constructors here. I'm going to skip over the getters and setters and stuff for now, and we're just going to write some equals, the equals method. Now, the equals method is public. It returns true or false, which means it returns a value of type Boolean. It's always equals, all lowercase, and it always takes a parameter. Now, there is a rule now about equals methods that I'm not going to tell you, so we're going to do it the basic way, and later when you get better at programming, you can come back and say, Mr. Azar, you never told me this, and I will confess. So right now we're going to say that this takes a rectangle object, and we're going to call it other. And the idea here is we need some code in here that determines whether or not this rectangle, the one that is having its equals method called, right, this one, is equal to other, right? Some other rectangle is going to be passed in the parentheses here. Well, for two rectangles to be equal, essentially all four of these variables have to be equal to each other. So we could write it with an if statement. So notice what I've got here. I'm saying that if the x-coordinate in this object is equal to other's x-coordinate, and if y-coordinate's value is equal to other's y-coordinate, and so on and so forth, then I'm going to return true. I've spaced this out just to make everything kind of easy to read. Again, remember that one element of white space is the same as an arbitrarily large amount of white space in Java, so that's no problem. So this is okay, I'm just spacing this out. We want to return true. That means we need else return false. And this is essentially what an equals method is. And it's kind of nice, I think, in this case, if we write this dot. Look at how nice that is. I've got this dot x chord, this dot y chord, this dot width, this dot height, and then other dot x chord. The idea here is that when you have an equals method, you're always comparing two rectangle objects, but one of them is the subject of the sentence and one of them is the object of the sentence, right? One of these rectangles methods is having its equals method called, and then some other rectangle method is just being passed in the parentheses. So this represents the object whose equals method is being called at that time. And because of that, it's really nice, I think, in this case to write this dot just to keep everything clear. Now, this is kind of the ordinary way that students tend to start writing equals methods. If you think about it, it's a little redundant. Remember that an if statement takes some Boolean expression in its parentheses, and then it only executes if the value inside is true. So think about what we're saying. If all of this is true, then return true, else, if all of this is false, then return false. Do you see how that's a little redundant? So take an eye on that. You can pause this if you want, but there's a kind of faster and cleverer way of expressing this stuff, which is we delete all this and we simply return this whole expression. And the idea here is this whole expression is going to reduce down to true or false. And if this whole expression reduces to true, we want to return true. And if this whole expression reduces to false, we want to return false. So this is a simplistic but working equals method for the time being. I do want to emphasize one other thing. Notice that we are accessing the instance variables directly here. This is also not as good of style as we could possibly do. It's much better style to always access variables through their getter methods, just in case there's some kind of error checking or value adjustment that happens within the method. Now I'll pause the video and write it, and then you can take a look at what it should really look like. Okay, so I've gone ahead and added accessor methods for all of the instance variables. You see get x chord, get y chord, get width, and get height. They're all public and they return their data types. And so now it's better. This is a much better way of writing the equals method. We write equals, and then we say get x chord, get y chord, get width, and get height for both this and other. And the idea is that there might be little adjustments that happen in the method for one reason or another, and it's better to incorporate those adjustments when comparing equals. And you just generally don't want to be accessing your variables directly in any way, shape, or form except through their official getter methods. So here we go. So that's an equals method. The other kind of method we talked about was toString, and again, the idea of a toString is just to return a string that generally describes the object in its current state. So this has to be a public method. The return type has to be a string because it's returning a string. We call it toString. It's like it's two words, and so you capitalize the string. You don't put anything in here because you're just asking information, not putting any information in. And then you just form some string that contains all the current instance variable information, or at least the critical instance variable information. So in this case, we're just going to return a string, and it's going to say, so this is an example of a toString method. So all I'm doing is I'm returning a string. This whole thing, all this code just generates a string for me, and I've kind of spaced it out in a clever way just so it should be easier to read. Hopefully it's not harder to read. But create this little string, top left corner, open parenthesis. I go get the x coordinate, and then I add on to that string a comma and a space. Then I add on to that string the y coordinate. Then I add onto the string a closed parenthesis and two spaces. Then I add onto the string width, colon, then the width, comma, space, height, get height. And you'll see that when I run that same method we did before, right? If I go that rectangle tester method I executed before, so it still says if rect1 dot equals rect2, and we're going to print out they are the same or they're not the same, and then I'm going to print out a description of rect1, you'll see that they are the same. So now the equals method is determining that those two rectangle objects are indeed the same, and it's also reporting that the top left corner is in 1,2, the width is 10, and the height is 10. So now these methods are performing in a productive way.